So let's start friends today with some another properties, and topic of the today is some another properties and examples. If you don't see my other videos, please go through my playlist, and there is also given the series from first to today's video. So let's begin. The properties of expectation is not so much tough, but you have to remember this. I am going to revision you the all properties that I have discussed in my previous video. So if x is equal to c and here c is constant, then expectation of x is equal to c. Number 2, if x is equal to cx, comma c is being a constant again, then expectation of y, say yourself what will be. This is as simple as that. This is y is equal to cx, then expectation of e will be, expectation of y will be c into expectation of x. Sorry. And again, number 3, if z is equal to x plus y, where x and y are a random variable from the same sample space. Why the same is important, I have discussed in previous video. Go and see. Define on the same sample space, then expectation of z is equal to expectation of x plus expectation of y. And today we will discuss some new properties like if y is equal to x plus bx, then expectation of y is equal to a plus b bex. And another property, that is fifth property, and it is the last property, z is equal to xy, that is of summation and that is multiplication. Nothing else is different. Where x and y are independent random variables defined on the same sample space, then this is for same, this is sample, and this is for space. Don't be doubtful, doubt will kill your energy. Ex is equal to Ez, expectation of z is equal to expectation of x into expectation of y. So you know what, number 3 and 4, there is some specific rule, like this is summation and this is nothing but multiplication. So this is called as sum law, and this is called as product law. Kader, whose, this is of expectation. So next we should move forward with some important results of variance also. So Let's check out what is variance. I have discussed in my another video, but still I am going to give a revision of is variance. It's not damn clear. This is giving us a neon vibe. Variance. What is variance? I have said variance is used to check the expectations. Means a value which is given, how much is satisfied by expectation, this gives us the variance. Variance is nothing but, if I say a variable x, then the variance of x will be expectation of x minus ex and whole square. So this is actually mean, because expectation give us the mean value that behaves like a central tendency. So we are saying this, that expectation is mean. So we move forward with some important results of variance. Some important results. Number 1, if x is equal to c, comma a constant, then variance of x is equal to 0 implies that x is equal to c with probability 1. If x is equal to c, a constant, then variance of x is equal to 0. And this implies that means variance of x is equal to 0 implies that x is equal to c with probability 1. Number 2, if y is equal to bx, then variance of y is equal to b squared minus b squared into variance of x. That is sigma y b is sigma x. B is in the mod and this is sigma x. We will prove it after writing all the results one by one. Then we will discuss the proof also. And at last, y is equal to a plus b x. Then variance of y is equal to b square variance of x. Then variance of y is equal to variance of x. So first we need to do some example handwritten. So now we are going to the example part. Here you can see I have written all the formulas. If you don't understand the formulas of expectation, this is too much easy to understand. Just give your full concentration on this session or video. You will understand all of these. This is nothing so much complicated. If you see here, expectation variance of a random variable x is equal to 0, and this implies x is equal to c. C means a constant. C for constant. And if you see here, x is equal to bx, this is the equation that you have given. Variance of x is equal to b square variance of x, where variance of y is equal to b square variance of x. That is nothing but if you under root this, that is what you will get. So there is nothing so much complicated things here. You have to just remember and understand all of the points to do more efficiently the problems. So let's move forward with the examples. The example which I have given or you have given, uh, wait a little bit. Okay, before doing some example, we have to prove all the handwritten formulas that I have written today. So let's move. These three proof I have already given you in the previous video. So we must start today from east. So please understand the topic what I have written. This is if x is equal to a plus bx. If x is equal to bx, then ey is equal to a plus b expectation of x. So let's do it. Otherwise, it will get some sorrows that I have not, that Sanjiban does not prove me. So let's prove it. There is too much simpler example. Simple to simpler example of proving this sum, this type of sum, is x takes value. This means x takes some value, expectation of x. I have to prove an expectation of y that is in left hand side and all other things are at right hand side, and x takes some values 1, x1, x2, x3 dot 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 with probability probability x is equal to xi. So then expectation of y what is the formula you everybody knows? P probability capital Y is equal to capital small I, and now I have to put all of the values here. That means what? That means a plus b xi, probability of a plus bx is equal to a plus bxi. Here you have to notice one thing, that I have deleted b and b. That should be done only when the condition is given. Okay? Otherwise, if b is equal to 0, then this one will be y is equal to a, and expectation of y will also equal to a, because this is only behaves like a constant, and you everybody know the constant of expectation itself the constant is. So let's move forward from this step. P x capital X is equal to small xi. So this is nothing but I have to multiply this here, and finally we will get okay. Is it not? If it's not so much clear, then go through the previous videos and that will give you a clearance. I am not going to the elaboration process, so that this video because of this video is going to be too much longer or healthier, so I am not going to the elaboration. Check out my previous videos and go to the topic one by one. So the first proof is done. Take a screenshot or note it down, and after that I am going to the another proof, that is the product law of expectation. Okay, now I am going to the another topic, that is product law of expectation, that I am done. I will do. What is product law of expectation? If this is also a renowned theorem, well known theorem it's also. So product law of expectation means if x and y are independent random variable, then expectation of xy is equal to expectation of x into expectation of y. This is the theorem, and we need to prove this. Suppose x assumes the values x1, x2, x3 dot 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 up to xk, and y assumes the values x1, y1, y2, y3 dot 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 up to yk. YL, sorry, YL, this is up to YK and this is up to YL. Suppose P probability capital X is equal to Xi, Y is equal to Yi, then that will be this one takes X's value and this takes Y's value, as simple as that. So here I runs from 1 to k, okay, and z runs from 1 to l. Since x and y are independent, then px pij is equal to now the product law xy is a random variable that assumes kl values with respective probability pij. So by the definition of expectation, this is I and this is J. Let's check once. My board is not working now. So in the next part I will do so in the another part I am doing nothing special. I am just I am just you can say distributing these xi from these to these and this for these to this. So yeah, next step will be our expectation, and this is also our expectation of x and expectation of y, so it's also proved. So don't forget to like, subscribe and comment this session and stay updated with me. And then I have to prove today these three properties of variance. This is nothing tough. You can say this is some conceptual topic, and we are going to discuss it. So let's start with probability 1. So let's start. If x is equal to c, then first proof. Here you can see x is equal to c. This single value, that is x, is taken. Sorry. And now we should prove it. That is some basic logic. I need to copy it. So here you have to put it and dragging this as becomes so much large. And now I have to prove it. So let's prove it. This proof is so much simpler as you do a plus a, that is nothing but 2. Take this easily, and let's begin with some with going don't be confused, don't be confused, because confusion kills your energy. And other things also. So if x is equal to c with probability 1, and then x expectation of e is equal to c is equal to mu, say for n, say this is can let you also say. So now variance of x is equal to e expectation of x minus expectation of x square. This is the formula we know. I am giving you x is equal to c. So expectation of x is also expectation of c, where c is constant, that is also given. So we should write here only c as the first law of expectation. If you don't see this, I am repeating this many times, that if you don't understand these, go through my videos that I have uploaded in this playlist of probability distribution class 12. So here x minus c, and expectation of these will be nothing but, this is the formula, x minus whole square p capital X to xi. There is nothing so much tough, this is as simple as that. Next step, should write here c minus c square 1 is equal to 0. Now if variance of x is equal to c, expectation of x minus mu square is equal to 0, summation I runs from 1 to infinity xi minus xy minus mu তার whole square p probability this is greater than or is equal to 0, we know. This is also greater than or is equal to 0, that we also know. And after knowing this, we can write here we can write here this and this, letting x not is equal to 0. So what will be, this will be equal to 0. Why I am writing this word? Because if I say this one is going to be 0, then this will be an impossible event that is not occurring here. So can it be done? That is obviously cannot be done. So we have to notice this such of controversial points to be so much confident about your knowledge. If you think minutely, you will find it easily. So let's begin with the next step. Then x I minus mu square is equal to 0. Then xi minus mu is equal to 0 and xi is equal to mu for all I. But this is not true observed value of x. And then from these we can conclude x is equal to 1. So is it right now? It is clear now. If it's not clear, go through the previous topic and see my lectures on that. So here you can see the proof was over here, but I have written this also. If this is also given, then you can prove it also. So next we move to the our second property, or property number 2. What is that? Let me check once. This is one of the property. That is nothing but property number 2. If y is equal to bx, then there is a relation between if and then. I have bolded because of your uh, comfort. If x is equal to bx, then variance of y and is equal to b square variance of x. So let v y is equal to e y minus y square, and then taking common, that will be, and after that because sigma x, that means standard deviation of x, and the square means the square, and that is variance of x. And then variance of y is equal to b square of vx, means variance of y variance of x, that is nothing but standard deviation y is equal to mod of b mod of x. Proved. These I have also proved these. Okay, let me bold it. So the left one is if y is equal to a plus bx, then v of y is equal to v square of vx. I have done is over here. Just you have to put here just a. So let me copy. So I have to just some values here. A plus A plus. Okay, I am erasing this, otherwise you may fall in confusion. So this will be e of x a plus vx minus a minus v expectation of x square b square. This will be cancelled out, x minus x square, and this will be variance of y is equal to b square variance of x, variance of x. So we are at the end of this session, and I think number 3 property of expectation is also left to be proved, to prove. So let me complete this also. Sorry, where should I prove it? Variance and expectation. So these, from this one, let me take some space. And this is the property. So let me prove it. Before proving, we have to know what is called, this is called sum law of expectation. If x takes some values x1 a x1 x2 x3 and dot 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 xk, and y takes some values y1 y2 y3 dot 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 yk, sorry l, and let p of capi x capi y, that is nothing but then I is equal to 1 to k, and j is equal to 1 from 1 to l, and this is summation pi j. I have bolded it because you know this one is 0, so this will be their summation, denoting by this. So next this will be and another part is summation I pj y is equal to yi. And then the sum of random variable x and y, whether random variable, that assumes KL values as with respective probability this. So by the definition of expectation of x plus y is equal to summation I summation j xi plus pij is equal to summation I summation j pij plus summation I summation j yj pij, and after that from these we know this one and this one plus summation this one and this one. This is j and this will be I. This is basic of mathematics of summation. You must know that obviously. And this was written previously here. So let me put the value. And the last one is ji p0j. This will be j, and this is nothing but expression of x plus expression of y. So this is also proved. So this session is ended here, has ended here. Thank you for seeing this video, and if you like this video, please like, share and subscribe also. धन्यवाद.